Okay, so first off, I'm going to start off talking about some math. So here we go. Let me share screen. How do I do that? Can everyone see my whiteboard?
Yeah.
All right, cool. Well, yeah, don't be afraid to like just interrupt me and speak up if you have any questions. I will answer it as long as it's not too chaotic. It's really not a problem. You can interrupt me whenever you want. Yeah, I'm also not really sure of your guys' background, so if I'm going too fast or if I'm going too slow, just let me know. Okay. So all right, here we go. So first we're going to talk about something called propositional logic. Okay. So this is one of the it's probably the simplest form of logic, and that the only thing we only have two values for the truth of a statement. Okay, so a statement is either true or it is false, and there's nothing else, and we assign and in propositional logic, we typically, what we do is we work with sentence, these things we call sentence symbols. Okay, so they're basically just variables to represent some sort of sentence, right? It's called the sentence symbol. So let's say we can have like A1, A2, A3, dot dot dot, AN. These can be our sentence symbols, and each individual sentence symbol can represent any sort of sentence, right? So maybe I can say A1 means the dog is red. And A2 can be, I don't know, whatever other sentence we want to deal with. Maybe the cat is, oops, the cat is, the cat weighs 5 pounds. I don't know if that's a reasonable number, but right. So these sentences, they can be either be true or false, right? Either the dog is red or is not red. So A1 would be assigned a value depending on whether the dog is red or it's not. And similarly, A2, well, if the cat is actually 5 pounds, we will treat A2 as a true statement, and if the cat is not 5 pounds, then we would treat it as a false statement, depending on whatever the actual truth of the sentence we're using to represent it, right? And so with these sentence symbols, oops, did my screen disappear? Oh man, my computer is misbehaving. Do you guys still see my screen?
Yeah, I still see it.
Okay, but I don't see it anymore. Sorry, give me 1 second. Is it back? Okay, it's back. What was I saying? Okay, so we're working with these basic sentence symbols that represent sentences, and then when we want to represent like logical statements, we also work with these things called connectives. So they're called sentential connectives. Okay, maybe I should put that on a new page. How do I do a new page? Sentential connectives. All right. So these sentential connectives, or they combine statements, right? So there's this upside down V, which means and, there's this V-shaped sort of thing, wedge. This means or. And you won't, there's also, hold on, there's also this little, I'm not sure what that symbol is called, but it's like a sideways reflected L. And this means not. And you won't see these as much in computer science or when you're programming, but they're important in like in just logic and if you're doing math. And those are like, there's implication, this arrow, right arrow thing, which also is if, then. And then there's also double arrow. Oops. Which means if and only if. All right, so I'm going to explain what these mean. Okay, so the and statement is pretty similar to what and means in English. So if you take two, you take two sentence symbols, and then you join them, they connect them with the and statement. This gives you a new sort of formula, a logical formula that also has its own truth value. Okay, depending on what the truth value of A1 and A2 are. So the truth value of this whole sentence. Can you see when I point at the?
Yeah, I can see your mouse
screen.
cursor.
Okay, so yeah, so this whole sentence is going to be true whenever both A1 and A2 are true. Right, so that sort of makes sense, right? If my A1 sentence means the dog is red, and my A2 sentence means the cat weighs 5 pounds, well, when is it true that the dog is red and the cat weighs 5 pounds? Well, that statement is true when both the dog is red and the cat weighs 5 pounds, and it's false whenever one of those things is not true, right? If the dog is not red, then it's not true that both the dog is red and the cat weighs 5 pounds. Does that make sense? Sort of a lot of wordy.
Yeah, that makes sense. I get it.
Yeah, okay. And so that's the and. So and similarly, we can also actually extend this to like any sort of what we call well-formed formulas. So if A is made up of things that like have their own truth values, you can also, it also makes sense to say A and B, but you probably don't have to worry about that too much. It's a bit complicated, maybe. So yeah, you can just think about like combining sentences. But yeah, actually, yeah, maybe I should give an example of that. So I can also do things like A1 and A2 and A3, right? It also makes sense to say something like this because then I can go inside the inner parentheses, figure out the truth of this statement, and then depending on the truth of this statement, I can also compare it to the A3 guy and also determine the truth of the whole statement. So I can sort of nest those statements also with these connectives, and it works with the other guys too. But I think usually when you're programming, you probably won't see too many nested statements, but you're gonna come up with some. You're gonna run into some, depending on how far you go, right? So that's one thing that can happen. Okay, actually, let me start a whole new page. Does that make sense to everyone so far, what I said?
Yeah.
Okay, cool.
Yes.
All right, so moving on to the next connective. The next connective is or, right? And this, I mean, these are basically designed to be similar to English or, but this one is a little bit different than English language because it's I think usually in when you're saying English things, sometimes you mean that here, let me just explain it. So if we have A1 or A2, then this whole statement's truth value depends on if so this whole statement is true if one of either A1 or A2 is true, but it's also true if both A1 and A2 are true. Okay, so actually maybe this is better if I do this. A1, A2, then A1 or A2. Okay, so if A1 is true and A2 is true, then A1 or A2 is also true, right? If A1 is true, A2 is false, then A1 or A2 is also true, because one of them is true. If this guy is false and this guy is true, then this guy is also true, because A2 is true, so one of them is true. And A1 or A2 is false only if both of them are false. So if we get both A1 and A2 are false, then A1 or A2 is false, right? And going back to the dog and cat example, right? If we say A1 represents the red dog, dog is red, and then A2 is cat weighs 5 pounds, then this statement is, well, the dog is red or the cat weighs 5 pounds. And in English, sometimes when we say that, we actually mean exclusive or. In English, like if I say the dog is red or the cat weighs 5 pounds, sometimes people might think, right, the dog might be red, but if the dog is red, then the cat must not be 5 pounds. But in this case, our logical or, it means that like if one of these statements is true, then the whole statement, the dog is red or the cat weighs 5 pounds, is a true value.
I have a question though, just to make sure that I got the and part right.
Yeah, go ahead.
And if one of them, it doesn't matter if one of them is true and the other's false. If there's even one that's false, both of them are false. But if they're both true, then that's the only way you can get a true statement in that case. Does that make sense?
Yeah, it's like this. Okay, maybe I should be more precise. So when I have just one sentence, I can assign a truth value to this guy, right? So this guy can be either true or it can be false. But when I do something like A1 and A2, this whole like I guess you can call it a phrase, or this whole sentence, like A1 and A2, is also assigned a truth value that's either true or false based on what A1 and A2 are. Okay, so if we have that both A1 and A2 are assigned the value of true, then the whole statement is assigned a value of true. But if either one of these is false, is assigned false, or if both of them are assigned false, then the whole statement is assigned false. So yeah, you're right that if one of them is false, then the whole combined statement is also false.
Thanks, I appreciate it.
Yeah, sure, no problem. Okay. So yeah, actually I can draw a truth table for that also. So oops, why is it misbehaving? So for and, we have A1 and A2, right? So this table, if I assign A1 is true and A2 is true, then A1 and A2 has a value of true. And if A1 is false, A2 is true, then the whole thing is false, right? if A1 is true, A2 is false, the whole thing is also false. And then if they're both false, then the whole thing is also false, right? And that's all the possible combinations I can assign to 1 and 2. So yeah. So this is called a truth table, right? So like if you're building up large expressions from these sentences, you can go ahead and, why is my computer misbehaving again? Ah. All right, sorry about that. We're back. So yeah, this is a useful tool, especially when, okay, maybe not, especially when when you're using a lot of connectives. What you can do is you can draw a table like this, and depending on what you assign each guy, you can individually like determine, right? So you assign true to this guy and true to this guy, and you keep track of what you assign each thing, and then you can like determine what this whole thing is assigned, right? This represents all the possible assignments. So A1 may be true, but it may be false, and then A2 may be true, but A2 also may be false, depending on what statements we're using. So yeah, okay. The next one, oh, I should have done this first, but the next one is not. This one is easy. So not A1, it takes only one sentence, and it just outputs whatever the opposite of A1 is, right? So if A1 is true, then not A1 is false, and then vice versa. So if A1 is false, then not A1 is true. Okay, so I mean, this is a pretty simple truth table. It'd just be false, then you flip it, and true is false. Pretty intuitive, right? I mean, same as the not in English. Yeah, so maybe I'll quickly go over the last two because those are not as important in this, but maybe it's probably a good thing to know. So last two is A1 implies A2, or if A1 then A2. So if this one, this whole statement is true whenever either A1 is false or A2 is true. So it's only true in these cases. So anything else, so if A1, or actually, I guess it's better to draw a truth table. The only case where it's false is actually if A1 is true and A2 is false, right? So let's go true, false, we get false, and then anything else gives true. And I think in English, right, it's basically an if-then statement. So if this bird is a crow, then it is black, right? So if it is true that the bird is a crow, then
Then it must be black.
Yeah. Sorry, my computer keeps like freezing for some reason. Yeah. So okay, let's say if this bird is a crow, then it is black. Right? So if we hit this statement is true if only if we don't actually see any crows that are not black, right? because basically what this statement is saying in English is that every bird that is a crow must also be black. Does that make sense? Right. So if it is the case that we find a bird, if it is the case that we have a bird that is a crow, and it's not black, then this whole statement is false. Because our statement is saying if this bird is a crow, then it must be black, right? Does that kind of make sense? Sort of. I guess logic is kind of abstract and weird at first, so it might be kind of confusing. But yeah, it is pretty related to English. Okay, so that one, and then there's also A1 if and only if A2, and this one, this whole statement is true only when A1 and A2 have the same value, right? So if A1 is false and A2 are both so if A1 and A2 are both false, then it's true. If A1 and A2 are both true, then it's also true. But if one is true and the other is false, then the whole statement is false. All right, so those are the, oh, that took a while. Okay, those are the propositional logic symbols, right? And okay, yeah, so that's a short introduction to propositional logic. Okay, yeah, so those are the symbols. I should probably go over the yeah, okay, so you can actually combine those symbols in many different ways, right? So if I have let's say A1, A2, A3 are my sentence symbols, I can also like put connectives like A1 or not A2 and A3, something complicated like that. And you basically just do order of operations based on the parentheses, right? You should, so this is the innermost parentheses. So actually, yeah, let's do this example. So I assign true to this guy, false to this guy, true to this guy. I'm just randomly assigning those. So let's say A1 is a true statement, A2 is a false statement, and A3 is a true statement. So gotta try and decide what this whole statement, the truth value of this whole statement over here. All right, so let's go by the innermost parentheses. So you start off evaluating the innermost parentheses and just move outwards, right? So A2 is false, so that means this not A2 must be true, right? So it's A1 or a true statement and A3. Okay, so A1 is a true statement, and then this is or a true statement, so actually it doesn't matter what A1 is, so this whole thing is a true statement, right? And then A1, so this is a true statement and this guy, which is A3, and A3 is a true statement as well. So this becomes true and true, which is true. Right? Does everyone follow?
Yep.
Okay. Yeah.
So,
Go ahead.
with the negation, in A2, so since A2 is false, but there's a negation, is that like opposite equals positive, or like, does that make the false true?
Yeah. So the negation just flips it, right? So if I have a statement, A1, A2, right, and A2 is assigned true, then not A2 is assigned to false. And then if I keep going, like if I assign not A2, then it flips back to true.
Okay, I have a question about the or. So were you was it that in like common English language, most people think that when you say this or this, that the assumption is that if one is false, then the other is true, or if one is true, then the other is false. But in logic, it's the idea that at least one has to be true.
Yeah, you're right. Yeah, you're right. In common language, I think it also depends on the context. But if I say like I'm going to the park or I'm going to the grocery store, right? You're not assuming I'm gonna do both.
Right.
But
Technically, in logic, if you did do both, then it would still be a correct statement.
yeah,
Okay.
yeah, you're exactly right.
All right. Thank you.
Okay, so
I'm a little confused on. Actually, I can research this on my own time. Sorry.
no, you can ask. Go ahead and ask.
The implication, I'm still trying to figure out how that works. Or sorry, not the implication, the arrow with just goes the ray, I guess. I don't know what the
Oh,
terminology for it.
this thing?
Yeah. No,
Oh.
it's not the line, the ray. It's
The
just one
implication.
arrow. Oh, that's what it's called, implication.
Yeah. Okay, so
I'm still a little confused on how that works.
this one?
Sorry about that. Yeah.
Oh, you're okay. Okay, so did I draw the truth table for this?
Yeah, you did, and I'm trying to understand how it works.
So maybe can I come up with a better example? Maybe I'll just say the crow, or
Like,
okay.
could we
Go
do
ahead.
it'd be like, if it is raining, then there are clouds, Like, would that work?
If it is raining. Okay, sure. If it is raining, then there are clouds. So we have this whole statement is true if when it rains, we also see clouds, right?
Right. So if A is true, then if A1 is true, then A2 has to be true as well.
Yeah, exactly. So what this is saying is this whole statement is true if whenever whenever A1 is true, then A2 must also be true. But the other case is if it's not actually raining, we don't care whether or not there's clouds, right? This statement is not saying anything about whether or not there's clouds when it's not raining.
Right.
So if A1 is false, then this whole statement is always false. I mean, always true, no matter what A2 is. Does that make sense?
Yeah.
Yeah.
All right. Yeah. Okay. Cool. And yeah, there's actually a bunch of like equivalencies between these sort of connectives. Maybe it's too complicated if I go through, but I guess I'll give one example. So if A1 implies A2, or yeah, if A1 then A2, this is actually the same as, or logically equivalent as not A1 or A2. So basically, if I assign the same truth values to A1 and A2, this guy will always have the same truth value as this guy, and you can check that, right? So, but it also sort of makes sense because this one is a statement that A2 is always true if A1 is true, but then we don't care about A2 if A1 is false. So in the or statement, or the whole or thing, the whole or statement is true if one of these guys is true. And in this case, right, if A1 is false, then we don't care about A2. So this whole statement is true. And then if A2 is true, then this statement must also be true. So these guys actually have the same truth value if A1 and A2 are assigned the same thing. So these are logically equivalent. Right. Yeah. Okay, so I'll give one, or actually two more important logical equivalences. These are called De Morgan's laws. And yeah, I'll just write them out. Pretty simple. So it's not A, actually, yeah. Not A and B is logically equivalent to not A or not B. right? And you can kind of check that. It makes sense, right? This guy is true only when both of them. I mean, yeah, this guy is true only when both of them are true. So that means if one of them is false, then this whole thing is true, because this guy becomes false and then the negation flips it, right?
So for the equal sign, it's like 3 lines.
Oh yeah, that means they're equivalent.
Okay.
So if I assign the same truth values to each of the sentence symbols on both sides, then both sides will have the same truth value.
Got it.
Yeah. And then also the other one is just negating the or. So this is equivalent to not A and not B. Yeah. And like the idea behind these two are basically the same. The not sort of the negation sort of distributes over the individual sentences, right? Okay. Yeah, this took a while. I'm gonna start actually coding. Okay. So here we go. All right. This is the REPL website, and I wrote some code up.
Do you want us to log in too, or just watch?
It's up to you. If you want to like play with the code as we're going, you can do that as well. And it does not seem to be loading. Why is it not loading?
Oh, and a question I have is, can you use any other letter? Oh yeah, you can. You already answered that. Sorry. I was gonna ask if you could use any other letter than A, but you used B, so yeah.
I mean, yeah, it's like a variable, right? You can draw a picture for all it doesn't really matter. It's just to represent. It's just a symbol to represent some sort of sentence that is either true or false.
All right. Just wanted to make sure. Thank you.
Yeah. So convention is like you use letters usually, but it doesn't actually matter. As long as there's no sort of confusion on like what you're talking about, right? If I use the or symbol to be a sentence, then it'll be very confusing to understand what you're trying to write. And I don't know why this isn't loading. Okay, well, while that loads, back to the whiteboard because it won't load. Right. So in computer science, like when you're programming in Java, you're going to use these sort of logic, this propositional logic to like do things with it, but this the way you like write the code, it actually looks a bit different than the symbols I used. So in Java, why is it not writing now? Okay, in Java, and is actually the two little, what do you call that, ampersands?
Oh yeah, that's an ampersand.
So you write it's two ampersands next to each other, but this is the same as the what I wrote as a wedge. Or is going to be two of those vertical lines in Java. Okay, yeah, so this is Java. It's the little, if you shift and the button, I think that's under your backspace. It's two of those guys next to each other.
What are they? They're
the vertical lines, it's above the forward slash, I think, if you shift in the forward slash.
Yeah.
And then the not or the negation is just an exclamation point. And then your sentences will be these things called Boolean objects. So Booleans are just things that either assigned a true or false. they have a value of true or false. So you can do like Boolean, what's a good example? I don't know. Boolean high equals true, for example. Right? So, and then Boolean, I don't know. Maybe I should, okay. Because I don't want to write an actual example. Like, I mean, I don't want to write an actual sentence, but. Right, and say A and B represent sentences. Then you can do system.out.print line A or B, for example. This will print, what will this print? This will print true, right? And then you can do similar things like that. Basically, the idea. Why is it still not loading? Sorry, guys, I'm getting a lot of technical difficulties with this laptop.
It happened to me all yesterday. So.
Yeah, I'm on a Surface, so I can write, but the Surface is like not a very powerful computer, so it's very, very slow.
Is there a reason why you put the not sign over the and, like between the and the colon, or is that like?
Sorry, what?
Is that the and symbol or is that the or symbol? That is. Oh, that is the and symbol. I just got confused. Sorry, that was my fault.
Yeah, so this is the logic symbol for and. This is a, oops. Why is it so bad? Draw, okay, this is the logic symbol for or, and this is the logic symbol for not. But it's an exclamation point for not, so you put an exclamation point. So if you do, if I want to print not B, right? I write it like that, and it'll print true. Yeah, I guess I'm gonna have to just whiteboard everything because the code I wrote is not loading. Okay, right. So why is this useful, right? It seems sort of like, I don't know, useless because everything is just either true or false. But it is useful because you can do like, so in Java you can compare things and it'll have a Boolean value. So you can do int a, yeah, let me do this, int a equals 1, for example. Oops. This is kind of frustrating. Why is it doing that?
For me, when REPL doesn't work, you have to usually refresh it multiple times.
Multiple times? I tried refreshing it. I think it's just my computer is not having a good time running both Zoom and Google Chrome.
Would you want to go on like a doc, like a Google Docs or something?
Oh, actually it loaded.
Oh.
Okay. So let me do that now. Okay, do you guys see that?
Yeah.
Okay, cool. So I wrote a bunch of oh, this should be down here. So I wrote a bunch of statements here, right? So I created a Boolean object, Boolean object boo1, and this is basically a sentence, right? And I gave him a true value, and I gave this guy a false value here. And then if I print boo1, right? Well, boo1 is true, so this guy should print true. Boo2, I assigned it false, so this should print false, right? And then down here I wrote some comparison things here. So this is like regular less than in math, right? So 3 is a number that is less than 4. So this guy over here is a sentence is a Boolean object that is true because 3 is less than 4. And then this will be false because 3 is not equal to 4. The equals is a comparison for whether they're the, like, instead of just 1 equals, because the 1 equals is used for assignment variables, right? So the 2 equals is the comparison equals. So this equals checks if the thing on either side is actually equal. So 3 and 4 are not equal numbers, so this should be false. Over here, yeah, this is, now I nested some stuff here, right? So 3, is 3 less than or equal to 4? Well, yeah, 3 is less than 4, so this is true. And then I put an exclamation point outside of it, so it flips this. So this should print false. And then, I don't know, do you guys want to try and figure out what the last two print?
Sure.
False.
Which one? This one? This one is false, you think?
Yeah.
Why? So remember, this is the or.
Yeah.
Because neither is true.
The one on the right is true.
Well, 3 is less than 4 though, right?
Oh wait, yeah.
Okay, so this one should print true. What about this one?
That's
That
false.
one's false.
Yeah, okay. And what about this one down here? So I assigned A is equal to 3 and B is equal to 2.
That's true.
No, that's
11.
false. That's false, I think. Is it?
No,
I
it's
hope
10
so.
is less than 11.
Yeah,
Should
3
be
plus
true.
7 is less than
Oh.
13 minus 2, right?
I
Yep.
keep messing up my math. I don't know. I
So
guess
I'm going to
never
run
went
this and let's see what it looks like.
That's true.
Okay, so I might have, okay, so the first one is true, second one is false, third one is true, fourth is false, false, this is false, this is true. Did I line everything up right? Yeah, this is true, so you guys are right. This is false, and this last guy is also true. All right, they're printed in order over here. All right, so that's that. Okay, I'm gonna comment this out, and I'm gonna get rid of. Actually, I'll skip this because I don't have that much time. All right, over here, this is an if-else statement. Over here, can you guys see that? I guess it's kind of small. Can you see it? Oops, why am I getting syntax errors? Oh, that's why. Okay, so over here I have an if-else statement, and the if-else statement is like basically one of the main ways that you use the Boolean values in when you're programming. So what it does here is I have this if guy, right? This if statement, and then I have a parentheses over here. So inside the parentheses, I put a Boolean valued statement, right? So back here, I created a scanner class and asked for a input of someone to type in what food is for lunch, right? So you type in something, and then over here it's checking. Does the food string does it actually say pizza, right? So this is a Boolean. This will return a Boolean object that's either true or false. So if what I typed in is the same as this string pizza, then it will print that food, that pizza looks delicious. Okay, and then but what happens? But it doesn't print this if what's in here is a false statement. So if over here evaluates, if this this clause over here evaluates to a false statement, then it will skip whatever's in the braces. Right? Does that make sense? So it's of the form if Boolean, and then I have braces, and then it does whatever is in the braces. and if Boolean is false, if Boolean evaluates to false, then it does not do what's in the braces. It just skips it and moves on, right? And then this else statement, so if I didn't have this else statement, it would just move on if this guy is false. But if I do have the else statement, then what it does is it skips what's going on in the first braces when it's false, but then it does what's in the else brace. Does that make sense? I guess it's kind of wording it weird, but yeah. So if else, if the Boolean here is true, I do what's in here in the first brace. If this guy evaluates to false, then I do what's in the else case. So right, if this is true, I do the first thing. Else, otherwise if it's not true, else I do what's in the else braces. All right, so I'm gonna actually run this code. So what's for lunch, guys?
Pizza.
Pizza.
Okay, so it printed that pizza looks delicious and did not print that the other thing which says that food looks disgusting. Now, if I type in something else, so what's for lunch that's not pizza?
Ramen.
Ramen?
Yeah.
All right, so that ramen looks disgusting. So it didn't print the looks delicious sentence, but instead it skipped it and went and printed the disgusting sentence.
Okay.
Right?
So what if I know Java's case sensitive. So if you typed in pizza with an uppercase P, what would that be?
It would actually say it looks disgusting. Yeah, we can try it.
Okay.
Oh, oops, my bad. I should have. Oh well. But yeah, I changed the wrong thing. But yeah, look, if I type the uppercase, see.
Right. Got it.
Yeah. So the way the comparison is it checks if it's exactly the same. And it does get kind of annoying if you want like things that are similar, because you have to because also if I added a bunch of spaces afterwards, it would also say it's different.
Okay. Got it.
Yeah.
It needs to be the same in every way.
Basically. Yeah, it gets kind of complicated doing comparisons things, because a lot of the times what we consider as like they're essentially the same thing, the computer in the computer it looks very different. So
Right.
sometimes you have to be very specific and tell the computer what we mean by basically the same.
Right.
All right, so that's the if else statement. And also, right, I think I said this, but if I didn't put an else case, it would just skip, and the food is not pizza. It would just like skip printing and it would just not print anything. Right, so the else case just catches, like does the other thing whenever it's false. All right, so let's add some complexity to the if else statement. So now we have an else if. So this little block of code here is a rock paper scissors sort of game, but your opponent always plays rock. I didn't feel like actually coding the an AI here, but your opponent always plays rock. So over here it asks you what do you want to play, and then you type in either rock, paper, or scissors. All right, and so once you type in that string. So what you type in is stored in RPS, okay? And so then we go into this if statement. It checks if what I played is equal to rock, then, well, since my opponent played rock, what it does is it'll say it's a draw, right? So if this is true, if the first guy is true, it's gonna say it's a draw. And once this is true, it's gonna skip all of the things afterwards. Right? So it's only going to do what's in the first brace. But if it's false, then it's going to go into the else case, right? But the else case is also an if statement. So it goes in here, and then it checks another thing. So now I'm going to check if it's equal to paper. Right? Now it does another check. Check, am I equal to paper if what I typed in is paper? If it's not, if it is, then I will print you win, because paper beats rock, right? But if I didn't type in paper, it's going to go and do another check. So it's going to go into this next else case and then check again. Is what I typed in equal to scissors? All right, so does this check? If I typed in scissors, it will go in here and do what it says to do in here, which is print you lose, because rock beats scissors, right? And if I didn't type any of those things, now it goes into the final else statement and prints this. Is not a valid rock, paper, or scissors move. So basically, in the if, else, else, it just goes one by one and checks each of the things if it's true. So if the first guy is true, then I do the first thing and skip everything else. Well, if it's not true, then I skip the first thing and go into the next one, check that, is that true? If it is true, I do it. If it's not, I skip it and then move on and keep going, right? So let's run this and play. So, all right. What do you want to play? What do you guys want to play?
Paper.
Paper? Okay. So you want to win. So you win, and Prince, you win, right? But now if I type something else, let's say
Rock.
rock. All right. So now we play rock. What does it do? Your opponent played rock, and so it's a draw.
Okay.
And now if I do scissors, now I lose. And then if I type in some nonsense,
Ramen.
if I type some nonsense, then it's gonna say it's not a valid rock, paper, scissors move. Right? Yeah, okay. So there's that code. So those are if else statements. So maybe I should give a more like concise way. So it's gonna be if and then Boolean and then braces, so it does whatever's in the braces, and then else if, and then another Boolean, and then it checks there, and then it keeps going, and then you can add the else at the end. And it will go one by one and check each of those like that.
What does the RPS dot equals, like, why is
Rock,
it?
papers.
Oh, okay, got it.
Oh yeah, RPS is what I stored your input as. See over here, string RPS is the next like scanner input.
Got it.
Yeah, and the dot equals checks if this RPS is the same string as this rock.
Got it.
Yeah. Okay, so last thing I'm maybe gonna go a little bit over time. So the last thing I'm gonna go over is the switch statement. Okay, so the switch statement kind of works the same as a if else statement, like I did back there. So I just wrote the same exact code, except here I'm using a switch statement instead of the if else if. So what switch does is, so it looks like this, right? I put a switch here, and then I put something in the parentheses. And what it does is it goes in each of these cases one by one. So it goes in order. So it checks, for case rock, it checks if RPS is the same as rock, right? So if it is, maybe I should indent this. If it is, then it'll do this thing. It'll do what comes after the case rock. If it's not, then it'll move on, right? So I have this break statement because what that does is if the case rock is true, so like if rock is the same as RPS, it will do this, but it will also keep going. But if I have the break here, it'll tell it to stop and just not do anything that comes after, right? So that's why I have the break there, and then it goes on. So else if paper is the same as RPS, and then it'll print you win, right? And then it does the next check, and it just checks them one by one in order. And then I have a default at the end, so you don't have to have a default, but what the default does is just, if none of these worked, then it'll just go and do the default, and which is just, it's not a rock, paper, scissors move. So this code will actually do the same thing as what it did up here. So we can actually try that. So play rock, it's a draw, right? And then if I do type in nonsense, and then it says not a valid rock paper scissors. So yeah, that's the switch statement. So this is not really that necessary. You can write it the same as this, but it does, if you have like a million cases, like writing if, else if, else if, else if, it's easier to just, like, this is like a nice shorthand, right? So yeah, I guess my time is up. Do you guys have any questions or anything?
Yeah. Would the program crash if you didn't have the default there and you put something else out of the, or would it just not respond?
No, so if I take this out, it just and none of the above cases worked, it'll just not do anything, right? So let me run that and type nonsense. It just doesn't print anything afterwards, right? So it doesn't say it's a draw, it doesn't say you win, it doesn't say you lose, it just does nothing. Yeah, so the default catches whatever, like if none of these cases work, then what does it do? Yeah, any other questions? Oh, I can also like send this code to you guys, I think, but actually, yeah, I will ask Mikey for like your emails, and I can send this code. Wait, where did I put my? Let me bring back my default statement. Oops. All right. And yeah, so if you want to like run things, I have these little // it's a comment. So I just turn this into a comment, which means it doesn't try to run this. If you take them out, if you take out the //, it'll actually try and run what's in between it. But if I put them back, it just ignores it, because when you're coding, like, it's good. I don't know if you guys were taught this, but it's good to like write in comments in your code, basically like notes if for yourself or if someone else is trying to read what your code, like trying to read your code and figure out what it does, you can like write sort of explanations here. But I just, and the computer won't try to run it as code. But I just didn't want it, I didn't want to make multiple files, so I just commented it out so it doesn't run it when I'm running the other things. But yeah, any other questions?
No.
All right, cool. Well, I hope this was helpful. Yeah, I think there's a lab section now gonna go on.
Yeah, Kevin, just make me host again.
Make you host? Okay.
Yeah.
All right. So yeah, Mikey, I'm gonna send you like my code, and like you could maybe send it to everyone so they can have an example and maybe play with it if they want.
Yeah.
So all right, thanks guys.
Thank you.
All right, bye.